Uh, Good morning, one and all. A warm welcome to day 2 session of our workshop. That is 2-day online national level workshop on Beyond the Cloud Edge Computing, which is held on 18th and 19th, organized by Department of Computer Science in collaboration with KHIT ASM Student Chapter. I think yesterday you have enjoyed a lot. We have the wonderful session on yesterday. Today also we have an eminent speaker, Dr. J. Srinivas Garu. I hope today also you will enjoy a lot. Now, today's lecture was delivered by Dr. J. Srinivas Garu. Dr. J. Srinivas holds PhD in Computer Science Engineering from Day-2 Anantapur. He has completed his Masters in Technology from Day-2 Hyderabad. Currently, he is working as an assistant professor in School of Computer Science and Artificial Intelligence, SR University, Warangal. He has authored adequate number of research papers in prominent areas of computer science. He has published 2 patents and waiting for the grants. His research interests includes cloud computing, machine learning, and algorithms. His students are placed in prominent MNCs and research organizations around the world. Now, I am welcome you, sir, Dr. J. Srinivas Garu. Please hand over this session. Sir, I am hand over this session to you, sir. Please hand over this session.
Thank you, Sanjan Garu, for the introduction. You have kept a very big responsibility on my shoulders. I know, and I think Dr. Krishna Kirti, she might have lived to the expectations. Okay. Am I audible, sir?
Yes, sir. Yes.
I think Dr. Krishna Kirti lived to your expectations yesterday. She might have definitely given you a wonderful talk, and students of KHIT might have enjoyed and might have garnered a lot of knowledge from her talk. I hope I'll also live up to the expectations. And at the outset, I would like to thank the management of KHIT to invite me for this prestigious workshop. And it's become a tradition. Dr. Subbareddy, the head of CSE, is conducting these workshops, and is imparting a lot of knowledge to the students of KHIT by conducting such workshops. It is always a pleasure to come to KHIT. So last year also I came and I have conducted one FDP, and before that physically I came and I have done one small workshop on cloud computing. So it's again, even though I'm missing the physical presence, but I hope I'll be enjoying the virtual presence also. And I thank Zubair Basha, Mr. Zubair Basha, the ACM coordinator, for his continuous support. And coming to the topic, my topic, right? So, yeah, is my screen visible? Yes, sir. Is my screen visible?
Just 1 minute, sir.
Yes, sir.
Okay.
No.
No, sir.
Yes, sir. Yes, sir. Sir, sir.
I'm sharing. Is it visible, sir?
Yes, sir.
Yeah, is it visible, sir?
Yeah.
Okay. Yeah. Uh, the theme of the workshop is very, very interesting. It is a very, very hot topic, that is edge computing. So beyond the cloud. So what is beyond the cloud? You all might have learned about cloud computing yesterday in Krishnakirti's talk. So that was all 10 years back, whatever, 10 or 5 years back. But now world is moving forward. So the next topic, beyond the cloud. So beyond means what is after the cloud. So after the cloud, we have something called as edge computing, fog computing, then intelligent computing. So like this, many topics are there, but we have selected only edge computing. So let's deal with edge computing. That itself is a very, very big topic, and it requires the whole semester to teach everything. But what I'll do is I'll just keep myself compact. So the key takeaways that you will get is you will have an introduction. Okay, you will have an introduction. I'll give you an introduction to edge computing. So, so what is edge computing? What are the current research that is going on edge computing? So from that you can build upon, all of you. Okay, students. Let's start now the talk. So what is edge computing? So today's scenario, looking at today's scenario. So everywhere you have these electronic devices. Everywhere you have these electronic devices. Each and every device is always generating data. It is always generating data, right? You can see here in this particular image, you have you can see here you have an industry that is producing, and it is giving some data that is going into a chip, right? Similarly, you have a manufacturing this thing unit, which is again generating a lot of data that is again being analyzed and going into a chip. Then you have autonomous vehicles, right? So these vehicles are generating again data, again that is being analyzed by some electronic device. Then you have these solar panels, that is you are generating some electricity, right? So all that data, what is the data, whatever data it is generating, again that is being captured by some electronic device. Then you have some meters here. You have some meters. You can see these meters. These meters are again, what are they doing? They are again generating a lot of data. So that data everywhere you see in your today's, in everywhere you have data. So all that traditionally you are storing in the cloud. Traditionally you are storing in the cloud. So this cloud will be present at a far location. Okay, this cloud will be present at a very, very far location. And what happens is, whenever you need to take a decision depending upon this particular data. Okay, whenever you want to take a decision depending upon that particular data. So in that case, as the cloud is very, very far, there may be a delay in the decision. There may be a delay in the decision. Suppose that this is a car that you are driving. This is an automatic car. Now it is not following the rules of the transportation. It is not following the rules of it. It has to brake. Okay, but you see, data is being transferred, and in the cloud, from the cloud, someone has to analyze that, and he has to send a command to brake. So it will take some time going to a data center, going to a cloud, and again coming back. The instruction coming back. It will take some time. So that is what is the problem happening in these particular areas. That is, whenever you are analyzing the data and you are going to take a decision, right? That decision has to come back to the location again. So in this turnaround time, that is called turnaround time. So this turnaround time is delaying the activities of these particular autonomous devices, right? You can see windmills here. You can see some temperature, some sensors, right? You can see in the building, smart buildings. This is smart lighting. So all these are dependent upon analysis, data analysis, and then taking some decisions on that analysis. So what is happening is, whenever this data is being sent to a remote location, that is cloud, and there you are computing, and again the results are being sent back, there is some delay. So that is a problem with your cloud computing. There is some delay. So to counter that, this new topic called edge computing came into existence. This new topic called edge computing came into existence. So what is this? What is this edge computing? So edge means corner, corner. Suppose that is the nearest point. So this is the edge. Suppose I have drawn this. So this is what is the edge for this particular shape that I have taken. Right? So at the edge of the cloud, what are you doing? You are putting some computing devices. You are putting some computing devices here. So that is called edge computing. Edge means to the corner. So suppose that, so previously the cloud was somewhere here in the center. All the computing devices were somewhere in the center. Now what are you doing? You are bringing this to the edge. You are bringing this to the edge. So that, how do you do that? How do you do that? So the computation is brought to the physical location. It is brought to the physical location of either the user or the source of the data. Either the user or source of the data. So what is the definition of edge computing? Edge computing is computing that takes place near the physical location of either the user or the source of the data. Previously, what was happening? Previously, there used to be a cloud. So in this cloud, all your computing was being done. So because of that, what is happening? Because of that, there is a delay in the decisions that you want to take. So what type of delay? What type of delay? Suppose that there is a manufacturing unit. Okay, so there is some gas leakage. There is some gas leakage. So you have to shut down. You have to shut down as soon as the gas is leaking. You have to shut down the manufacturing unit. But now what you are doing, you are relying on cloud. So all the data is being sent to cloud. The parameters, the sensors, they are sensing the gas, the density of the gas, the temperature that is present in the manufacturing unit, then the pressure of the gas. Everything is being sensed and it is sent to a cloud. So till that decision is taken, what might happen? There may be a catastrophe. There may be an accident occurring. So this has to be avoided. So for that purpose, what the researchers are doing is they are using this new technology, that is edge computing. Edge means corner. Edge means, what do you mean by edge? Corner. So where are you bringing this computing? You are bringing this computing to the source of the data, user or source of the data. So for example, this is the example here. You can see here there are again many areas. So here the same diagram, it is shown in a different way. So this is a speedometer. This is a car, autonomous car. This is an industry. Okay, manufacturing unit. Here you have some wind turbines. So this is also generating some data. Solar panel, electricity generation, water. All the data is being sensed. The data is being sensed. So if this particular this layer was not present, okay, assume that this layer is not present. Assume that this layer is not present. So all of this would have directly transferred to the cloud or the data center. So here all the calculations, what is X, what is Y, what is Z, all these calculations will be performed, and again that will be again transferred back. Okay, that again will be transferred back. But till then there will be a problem, that is there will be a jitter, that is there will be a delay in time. There will be a delay in time. So some accident might occur. So what we are doing with edge computing? What we are doing with edge computing? We are now bringing the computing to the physical location. That means we are putting some mini cloud or mini data center or mini, what you can say, computing devices. So you are keeping some mini computing devices. So small cloud, you are establishing a very small cloud, so that these type of decisions will be taken near the physical location of these particular things. Okay, so basically edge computing ante entama, edge computing ante మీ క్లౌడ్ ని లొకేషన్ కి తీసుకురావడాన్ని ఎడ్జ్ కంప్యూటింగ్ అంటున్నారు. సో మీ క్లౌడ్ లో ఉండే మెషిన్స్ ఏవైతే ఉన్నాయో అవే మెషిన్స్ మళ్ళీ ఇక్కడికి దీని దగ్గర తీసుకొస్తున్నాం, మనం ఈ పర్టికులర్ డివైసెస్ దగ్గర తీసుకొస్తున్నాం. సో ఇన్స్టెడ్ ఆఫ్ ట్రాన్స్ఫరింగ్ ద హోల్ డేటా టు ది క్లౌడ్ or to the data center, what we are doing, whatever can be done near the machine, near the device, or near the user's location, there you are doing some computation. So you are putting analytics, you are doing some analytics, you are doing some you are taking some decisions. Okay, you are doing some analytics. So basic analytics, not the main things, basic analytics, that will be done here itself. So because of that, time will be saved and lot of pressure on this data center or on this cloud that you are going to remove. Okay, so in short, what is edge computing? Computing near the user's location, physical location or source of data is nothing but edge computing. Okay, so edge and enti corner. So if this is your cloud, okay, if this is your cloud, so you are bringing all the computing resources to this part, that is the edge, so that it is effective. Okay, physical ka kaapayina virtual ga you are going to bring it. Okay, so so will I just say what is the use? So why are you using this? What is the use if I bring this edge computing to the physical location? What is the use? So simple, lot of time will be saved. Simple thing, lot of time will be saved. Accidents, you don't need to worry about accidents, because when you are taking timely decisions, automatically accidents will come down. Automatically the accidents will come down. Accidents means it is not just vehicular accidents, it can be any type of accidents. So what you are going to do here, you are again still here only, you are going to decide which type of the server is going to be given to which data, which machine is going to be given to which data. All that decisions you are going to take. So this layer, you are adding up a new layer called edge. Okay, in the original cloud computing, you are fixing one more layer called edge. Okay, so that is nothing but your edge computing. Okay, just to make cloud more efficient, you want to make cloud more efficient, so in that case you are going for edge computing. Okay, so what are the applications? What are the applications of this edge computing? Where can you use this edge computing? Ekkada use cheyachchu manam? So in which places can we use this edge computing? So you can use the edge computing in wherever you are having smart meters. So in your household devices, in your household, if you have these meters, you use the electricity. So then you are paying bill for the electricity that you have used. So instead of person coming to your house directly, you can directly the meter can give you the bill to your mobile. So that is called smart meter. So whatever, how much electricity you are using, depending upon that, automatically the meter will generate one slip. So instead of a electricity person coming to your house and generating that bill, your meter can generate that bill. So that is nothing but smart meter. So this here in this area, so what generally, how does a smart meter work? It will be sending all your data to the cloud. So instead of sending the data to the cloud, if you keep one edge here, if you keep an edge here, okay, if you keep an edge here, so that will compute all the bills of these houses, and it will generate the bill. So you don't need to go send the data to the cloud. So cloud can be used for other important purposes. Okay. Similarly, in the hospital, right? All parameters like what is the BP, vitals, what is the blood pressure, what is the oxygen level, what is the they are doing some tests. So what is the sugar? What is the sugar test result? So then what is the urine test result? So all that results, all that data analysis, you don't need to again send back it to the cloud. Just to put one edge cloud, small edge. Here also you see you are keeping one small edge cloud. So just extension of the cloud. So that means what do you have in this edge cloud? You must ask me, sir, question. Sir, what is there in this edge cloud? Nothing. You have small computers which are connected to the main cloud. Okay. So instead of sending all the data back to the cloud, what you are doing, you are using these data, that you are using these machines that are present near your house or near your location. So that is called your edge or edge cloud. Okay. So in smart health system, so automatically you can predict whether a person is going to get heart attack or kidney disease, or whether he is having any brain stroke, or all that can be done in near the hospital itself. You don't need to send again everything to the cloud. Okay. Then smart houses. So smart houses. So this is a new concept that is coming out. Smart houses, especially real estate people, they are now projecting their projects like smart houses. So in a smart house, you have you have some cameras, you have some digital locks. Okay, your electricity, water, all everything will be generated smartly. Smartly means it will be done through computers automatically. So that again, previously that data was again being sent to the cloud. So now you don't need to send this to the cloud. So directly there is a small, what you say, small computing, small data center. You can call it as a mini data center or collection of computers. So these things will analyze this whatever data is being generated in this particular smart home, and they will give the decision back. No need to go till the cloud and again come back. Okay. So that is what is about your smart house. Then you can even use these in navigation. Okay. You can even use this in navigation, that is monitoring of the sea. Navigation, monitoring of the sea. So whenever cyclones, there are any cyclones coming, any change in the weather, okay, you can use drones at different location. You can use drones. These drones will be sensing the what you say, the pressure, in the sea level, or the speed of the wind. All of that will be sent to a part, generally to a cloud. But again, you are removing the burden from the cloud, and you are putting a small, what you say, small edge here. You are maintaining a small edge. So this again is connected to the cloud. Okay, indirectly it is connected to the cloud, and whatever analytics has to be done, that is being done here in this edge cloud. Okay, that is smart sea monitoring. So you don't need to depend upon the cloud. So you can establish a small edge cloud here. Okay, and you can monitor the sea. Right. Similarly, transportation. So on the roads, okay, you can avoid collisions like this. Okay, if previously, now the age of autonomous vehicles, that is automatic vehicles, driverless cars, that is going to come. So during that time, all the cars will be connected to cloud. So cloud is somewhere, and it is located at a very remote location. So because of that, you can have some accidents. So in order to avoid such accidents, you can keep an edge cloud which is going to near that particular road. You can maintain a small edge cloud which is going to monitor this traffic. Okay. Similarly, in parking systems also, you can use this edge cloud. So you don't need to depend upon the cloud for everything. Okay, cloud can be used for industrial purposes, for high performance in applications which require high performance and all that. But yeah, for these small things, you don't need to depend on cloud. So that's why what we are doing, we are using this edge cloud. Okay, edge cloud. Then people, smart people. So every person nowadays has 2-3 mobiles. So everything is every mobile, every electronic device, laptop, tab, everything is generating smart watch. It is generating a lot of data. So that data is being analyzed. So instead of sending that to the cloud, what are you doing? You are doing the analytics here itself. You are doing the analytics here itself in the edge cloud. So that here you can use smart people. You can use your edge computing. So basically, when I say applications of applications of your edge computing, so very few areas I have touched. They are not limited. Everywhere data is being generated. So wherever data is being generated and it is being analyzed, you can maintain an edge cloud. You can maintain an edge cloud. So basically, extension of this particular cloud is nothing but your edge cloud. Extension of the cloud. Extension of the cloud. In cloud, it is full scale. Whereas in edge cloud, you have very small number of computers depending upon the problem or application that particular edge cloud is being used for. Okay. So till now, what I have explained you the today's scenario, how things are changing. Okay, today's scenario I have explained. Then I have given you a definition of edge computing. What is edge computing? Okay. Then I have explained you the necessity for edge computing, and I have given you the applications of edge computing. So far, I think I have introduced you to the edge computing. Okay, I have given you a very good introduction. I hope I have given you a very good introduction to the edge computing. So these are the applications: autonomous vehicles, remote monitoring of assets, that is in oil and gas, then smart grid, maintenance of predictive maintenance of the industries or any other structures, anything like that, predictive maintenance. Then hospitals, then 5G radio networks, then for gaming, then content delivery, that is OTTs and all that, content delivery, traffic management, smart homes. So these are some of the areas where edge computing will take a role in the future. Okay, will take a role in future. Now I will discuss with you about the prominent architectures. Okay, prominent architectures that in which you can build the edge computing. Okay, so basically you have two reference architectures. First one is centralized control plane. Second one is distributed control plane. Okay, remember all of this is still in theory. Most of this, whatever I'm speaking is still in theory. So that's why I'm saying reference architectures. Okay, centralized control plane, distributed control plane. So in two ways you can bring edge computing to the customer. So first one is centralized control plane. First one is centralized control plane. So in centralized control plane, what you will do is there is a central data center, okay, and you have multiple edge data centers like this. You have multiple edge data centers like this. So in the central, what are the jobs of central data center? So you have a controller there. You have storage. You have some storage management. You have a computing device. You have a computing device. You have a computing device. So this is the central data center. So what are the jobs? What are the jobs of a central data center? So it has to deal with scheduling or placement. So whenever there are some requests coming in, whenever there are some tasks coming in, like T1 task 1, then task 2, then task 3. So like these tasks are coming in whenever. So scheduling means giving the computer to this particular task one. So this computer is given to task one. This computer is given to task two. This computer is given to task three. So that is scheduling or placement. Okay, that is orchestration. Together we call it as orchestration. So orchestration means you generally see musicians, orchestra. So one person will be controlling the orchestra. So he'll tell which device to be played at what time. So similarly, T1, T2, T3, these are the tasks. So you are going to schedule these computers to these tasks. So that is what is orchestration. Then the second job is identity management. So from which source is generating that particular task or data. So that is called identity management. So you have your username, you have your password, basically accounts. So from where is that data or where is the task coming from? So that is identity management, right? Then image management. Management means sometimes you see this computer you are working on you are doing some your data center is executing this task one on this computer, but due to some reason this computer is shut down. So you don't need to restart this again. This computer 2 again. This T1 is not restarted on T2 on this particular second computer. So before this computer being shut down, what they will do? They will take the current state of this task one, that is called as image, and that image is transferred to this particular computer. That image is transferred to this particular computer. So the image of the task. So what image means? Not your photo. Image means at which point, what is the state of that particular application or task when this computer is going down. That is called as image management. Okay. Then you have then network management. Network management means so all these internal data. So all these devices are connected, okay, through a network. So that is inter data center network, and outside also you have some networks. So that will be managed by this particular controller. Then you have storage management. So if you are dealing with storage, that is data storage like Google Cloud or other clouds. So they store a lot of data. So that if you are into storage management, if your data center is looking into the storage management, then the controller also takes care of the storage management, right? So basically, your central data center, it has got two units: controller unit and then computing unit. Controller unit and then computing. These are independent computing units, right? So the job of the controller is to perform orchestration. The job of the controller is to perform orchestration, identity management, image management, network management, storage management. So these are the jobs. These are the jobs of the central data center. And what is the job of this computer? It is going to compute. So like this, a number of computers you have, right? Now this is connected to, this is your regular cloud map. So this is your regular cloud. In the regular cloud, in the regular data center, these things you will have these things. Now coming to the edge data center. So whenever I go for centralized, so this is this edge data center is extension of the data center. It is the extension of the data center. What do you have? So you only have computers. You see here, you have compute. You some places you will have the storage additional, but usually in centralized control plane, the edge data center contains only computers. So these computers are managed by the controller again. These computers are managed by the controller again. So instead of suppose that this is a device that is generating some data. Suppose that this is a device that is generating some data. Now this data need not go to this particular data center. So this you are now, this you are avoiding. Instead, it goes to any of these data centers, edge data centers. So which are nearer to it, which are nearer to it. So then, sir, you should ask me a question. So what is the difference between central data center and edge data center, sir? So central data center, you have all these, you have the control part, control aspect. Okay. So at a macro level you have, but edge data center is at a micro level. So its limitation, its functionalities are limited. Only computing, only computing. You are doing only computing here. So whenever I go for centralized control plane, all of you keep this in mind. All the orchestration, identity management, image management, network management of all these devices is again done by the controller. So that means this is controlled by this central authority. Okay, whatever I want to repair this controller, you have to contact the controller. I have to upgrade this, you have to again contact this controller. I have to shift this, or I have to change this. So again you have to contact this controller. So even though you are calling it as edge data center, okay, still all the decisions are taken here only. All the decisions are taken here only. So that is the description. All the key control factor is at the central site. All of the key control functionality is located in the central site. Identity management and orchestration is also done centrally. Okay, so is it so when you are saying it is bringing near to the location or customer, but still everything is at the center. So is it useful? Is it useful? No, it is not. But it has its advantages. What is that advantage? So security. Security. So whenever the data center is is at a far location, then all the data or the devices, you feel it as secure. Instead of suppose I am having here. So I want, so this is one data, this is edge 1, this is edge 2, this is edge 3, okay, this is edge 4. Now daily I have to go to these multiple locations for security. That means I have to use applications wherein at every location I have to install these. But instead of that, if I maintain one central, data center, okay, so only this area if I secure it, that's enough for me. So that is the important point, security. So whenever you are dealing with the applications that require security, so you can go for this centralized control plane. Okay, you can go for this centralized control plane. Okay, and everything is at one. Even though if you see, if someone hacks into this data center, or if they hack into this data center, if they take control of this data center, so the control is from this particular point, so they are not going to achieve anything. So that is the advantage of your centralized control plane. But if you what are the issues? So whenever data centers become large and large, so it becomes a very tedious, and automatically it will break. The data center will break down. So operating a big unit is always cumbersome. It's always very hard. And you see, uh, whenever there is a network failure, here, so all these data centers become dumb. Okay, they are not they don't work because there is no network. All the decisions are taken by the central data center. So because of that, when there is no network, all these become dummy. Okay, so what is the difference now? What is the advantage? Advantage means security. But what is the disadvantage? Whenever there is a network loss, whenever there is a network loss, there is a connection loss, your edge data centers, they are becoming waste. And flexibility, they are not flexible, very less flexible. Everything is static. Everything is static. It's not more, it's not dynamic. So these are the issues. These are the issues in centralized control plane. So once again, I'll just repeat what I have explained in centralized control panel. So I have given you an introduction to your cloud data center. So what are the activities of the cloud data center? So you have these activities 1, 2, 3, 4, 5. These are the activities that you have in cloud data center. This is the edge data center. Okati, rendu, these are the edge data centers. So whenever you are making an extension of the cloud data center, it is becoming edge data center. So whenever you go for centralized control plane, that is this type of architecture. So in this type of architecture, what do you have? In the edge data center, you have only computing devices. You don't have controllers. You don't have controllers. That you keep in mind. In centralized control plane, you have only controllers. You don't have controllers in the edge data center. Okay. So because of that, what is happening? All the decisions should again be made at the central facility. So that is one problem. And flexibility is also problem. So if you have anything to repair, you have any computer to be repaired, you have any computer to be upgraded, you have any software that is to be upgraded or reinstalled, so that has to come again from the central data center. That order has to come from the central facility. So because of that, this cannot be used where time is very, very important. Okay, but when you go for security, you want security is your priority. Okay, you want security. Okay, so in that case, this centralized control plane is preferable. Then coming to the next plane, that is a distributed control plane. Distributed control panel. So you can see the difference here. It is now a mini. This is a mini data center. You have everything. You see whatever you have here, you have here. It's a replica. It's like a replica. So this is the central data center. Now these can act autonomously. Okay, this can act autonomously. That means they don't depend upon the central data center. They don't depend on the central data center. They are flexible. They are flexible. The edge data centers are flexible. Decisions will be taken here itself. Here itself. So which computer, which task, which computer, which task, all that is done here itself. No need to go back to the central data center. But what happens is this is costly. Okay, this is costly. This is costly. This is costly. And maintenance, you have to again here the same thing, here the same thing, here same thing, here same thing. So everything is happening twice. So that maintenance problem is there with this. But what happens is time it is fast. Whenever you go for distributed control plane, it is fast. Okay, so that is a problem. But security and maintenance, as I said, security and maintenance, this is the problem. Security and maintenance is the problem here. And synchronization, because you see lot of devices are being added. So sometimes this data center it becomes overloaded. So that is the problem. So I have now explained you two types of architectures. One is centralized control plane. Second one is distributed control plane. So edge computing you can offer to your clients or customers in two architectures. Okay. So what is that? First one is centralized control plane. Second one is distributed control plane. So till now I have given you the introduction to edge computing. Then I have explained you the popular architectures. Now we will see some of the issues. These are the issues. So how work offloading, what is work offloading, what is resource management, what are the security issues? These we will see in the next slides. Okay. Yes. So going to the, okay, these are the okay, some of the challenges for the architectures: automation, remote provisioning, single pane of glass, remote upgrade, resiliency. So automation means, you see, more and more devices. So whenever you want to, so whatever the architecture may be, whether it may be central architecture or distributed architecture, edge computing has certain challenges. Okay, it has got certain issues or challenges. What are those challenges? What type of challenges it has to face? So more and more automation of things is happening. You are getting automation into every your daily life. So because of that, number of electronic devices, number of data, the size of the data is growing daily. So all of that should be managed. So that is what is the problem. So overloading, you are overloading. So you are overloading the already existing, your automation is overloading the already existing edge. So how to manage such volumes of data, or how to analyze such volumes of data? That is the first challenge that your edge computing has to face, right? Then provisioning, remote provisioning. Provisioning means assigning computer to a particular task. That is called as provisioning. So remotely, how can you manage this? So if you are going for edge computing, that means from a remote location you are serving the customer. So how to give him better service when number of customers are increasing? How to give him better service? That is what is the second challenge. Remote, from a remote location, you have to give resources to the customer. So you are not on the field, you are somewhere else. So your problems are now becoming double, triple. Okay. Then single pane of glass. So single pane of glass means you have only one interface. So you have to bring all these what you say compute edges into one one location, one pane of glass, that is into one interface. Okay, so how to bring that into one interface? So this, the data of edge computing 1, edge 1, edge 2, edge 3, edge 4. So from one interface, you should be able to manage all these edges. So that is the third challenge that your whenever you are thinking of giving edge computing to your client, that is what you have to keep in mind. Then upgradation. So you should not go to the site. Okay, you should not go to the customer's location or to the edge. Directly from the central data center, you should be in a position to upgrade the devices. So that is the challenge you have whenever you are going for edge computing. So sitting at your location itself. So that means, what does that mean? So sitting here, you have to upgrade this computer. Sitting here, you have to upgrade this computer, or sitting here, you have to upgrade the computer in this particular edge. There is no a single edge ledamma meeku. You have multiple edges, so that's the problem. Then resiliency. Resiliency means, so you will have network problems. Okay, you will have network problems. So how you are managing these network problems? Resiliency means how your edge computing architecture is tackling the network problem. That is what is resiliency here. Resiliency to the network problem. So how you are tackling the network problems? Because everything is based upon network. So you need something like 5G. Yeah, for this to work, you need 5G. But you see, 4G will not give you complete what you say 100% accuracy, you will be needing 5G for this. So in many countries still 5G is not introduced. So that is a very big problem. That is very big challenge for edge computing, for people to accept edge computing. Okay, so these are the challenges. Automation is first challenge. Remote provisioning. So from an outside location, you have to provide resources to the customer. That is the challenge that edge computing will have to face. Then single pane of glass means one interface. You should have one interface. Okay, then remote upgrade. By sitting at one location, different location, you have to upgrade machines present at different locations. Then resiliency means you how your architecture is tackling network problems, other architectural problems. Okay, so this is about the challenges of edge computing. Okay, then general problem anywhere, edge computing, fog computing, cloud computing, or distributed computing, all these have this common problem, that is computation offloading. So generally you see you have this edge, you have this edge, you have this edge. Okay, so edge 1, edge 2, edge 3, assume that these are three edges, edge 1, edge 2, edge 3. So the capacity for this edge 1 is 5. The capacity for this edge is 10, the maximum capacity. The maximum capacity for this edge is 15. Okay, currently there are 5 tasks: task 1, task 2, task 3, then you have this task 4, and you have task 5. Okay, you have this task 5. And in this particular edge 2, already it is filled with 7 tasks. Okay, already it is filled with 7 tasks. And this edge 3, already it is filled with 10 tasks. Now what is happening is new tasks, some task X, it is coming. So what is happening is this is being assigned to edge 1. This is being assigned to edge 1. But you see already 5, the capacity is 5. You are giving sixth one. You are giving sixth one to this particular edge. So this is not in a position to handle this. So now this has to offload. Edge 1, what it has to do? It has to offload. That means it has to shed its load. That means it has to remove some of the tasks. So how it is going to remove? So should it remove task 1? Should it remove task 2? Should it remove task 3? Should it remove task 4? Should it remove task 5? Okay. And so if task 1 is removed, should that be sent to edge 2 or should that be sent to edge 3? All that comes under this offloading, computation offloading. So this is a very big problem. Many papers, lot of research is going on to this. Many papers are written. So basically, what is this? What is this computation offloading? So whenever the edge decides to remove its tasks from the computer. So it wants to switch. It wants to divert its traffic. So what is the mechanism? You have static mechanisms. You have artificial intelligence based mechanisms. You have cloud. You have this smart computing mechanisms. A lot of things. Lot of papers are there. Lot of research is going on this. Still, the problem exists. So how the edge is going to offload its tasks? How is it going to reduce the tasks? So basically you cannot stop this task. Okay, you cannot stop this task. If you stop this task, then your edge is not efficient. So it will deliver it to, it will transfer the task to either nearby edge, either to the edge 2 or either to the edge 3, depending upon the decision. So all this comes under computation offloading. Okay, all this comes under computation offloading. So basically, what is computation offloading? The edge, it will try to what is a transfer some of its load to adjacent edges, or even to the center, even to the central, even to the data center, even to the center of the cloud. Okay, that is called computation offloading. So one example, okay, this whatever I have drawn there, this is the example. You see there are some already tasks there. So what is happening is how many tasks to offload. So these all tasks are coming. They are coming. They are coming into this particular edge. So these are prominent. Now these tasks are prominent tasks. So how many tasks to upload? Okay. How many? So again, so to whom? There is one more cloud here. So shall I send to this one, or there is one more edge cloud here? So shall I send to this one? So shall I send to this one or this one? That is also question. There's a big question mark. Okay. So so you have selected the task to be sent to this cloud. To this cloud. So then which tasks? Already there are some tasks. So which task should be sent? That is also a big problem. Okay. Then the second thing that you have to keep in mind is resource management. Resource management in edge computing. So you have a number of excuse me. One second, please. Yeah, sorry for that. So you have a number of resources in the edge. So that means resources means you have computers, you have servers, you're having virtual machines. So all that, how you are managing, that is a very big challenge in edge computing. So it comes with a lot of edge computing has a lot of infrastructure. So how you are managing that infrastructure? Why? Because these days a lot of demand is coming from the customers. So you are using AR VR, you are using AR VR applications, you are using IoT applications, you are using virtualization applications. So all these need a lot of computing resources. Okay, all of these applications require a lot of you need a lot of computing resources. So how to manage that is still under under research. So the optimization is not yet achieved. Okay, again, lot of research is going on in this resource management. A number of algorithms, a number of techniques are published in the literature. So if anyone wants to take projects, they can use this concept, this topic. So how because of the increased demand of the applications, how resources are managed in the edge computing? That is the question. That is the question. So your edge computing has to deal with that problem also. Okay. Then, so one example. Okay, I have taken this from a paper. So one example. So you can usually what is happening is there is you are maintaining a software called a software called resource allocator. So this follows some logic. Okay, this resource allocator is going to allocate the resources node or server to the to the user here. Okay, usually you see in the edge node. So you have the server pool. You have monitors. Monitor means that is going to check these servers. You have some these scalers, auto scalers. So depending upon the demand, you will scale up or you will scale up. That is, you will increase the number of servers, that is computing devices, or you will decrease the number of computing devices. Then you have this operating system that is required for managing the edge. Then the various applications that are running that are coming from the regions. So basically, you see here you have these regions. So you are whatever area that is present that comes under this cloud, it is divided into regions, user region 1, user region 2, user region 3, user region 4, like this, user region 10. So in between you are putting this, again I said, it is this one is a stuffed layer, edge layer between the cloud and between the computing devices. Okay, so you are bringing the cloud nearer to the user. So so basically what is happening is this resource allocator, it is allocating the nodes or the requested software to these to the computers or to the mobile devices or to the tabs that are present in the user region, or to the machines, okay, to the user region. Now here, what type of algorithm you are using, okay, that is not fixed yet. So that there is research going on. What type of algorithm, what is the logic this allocator is using? Still, a lot of research is going on in that area. Okay. Then security. So secure. The third thing that I'm talking is security. So I already said these edges are at the remote locations. That is location where the user near the user. So these are prone to attacks. Okay, cyber attacks. So people, hackers can take control of these edges. Okay, hackers, they can take control of these edges. So now your security system, your software must be robust. Okay, your whole architecture must be robust. That is, if one edge is going down, it is taken up by some hacker, then there should be another edge in that area that is going to come up. Or you should maintain antivirus or all that software that is going to help you. So still research is going on in securing the edges. Okay, that is one point. How, which security algorithms, which security mechanisms are useful, are the best, in that still research is going on. Okay, so basically what I have covered now is these three. So these are the three hot topics in edge computing. So how you are uploading the tasks or the load, the applications in edge computing, how you are managing the resources in edge computing, and what are the security, how you have to maintain the security, what are the issues that can come up in edge computing. So all type of these three research issues I have covered. So right, then these are the challenges, general challenges. So we need 5G, we need serverless computing, we need resource allocator, so that I have spoken about. We need to optimize, that is, all the infrastructure has to be used optimally. Then energy consumption. So because of that, we have to, because of the large scale architecture, large infrastructure, you will be consuming a lot of power. Your edge will be consuming a lot of power. So you have to use renewable energy like wind energy or solar energy. Okay, then data, a lot of data is generated, so that has to be managed. Then federated, you should maintain federation. Okay, then federation means again central data center is beneath that you have this edges. So this is called federation. Okay, so a federal structure you have to maintain. This is the edge, this is the cloud. So this type of maintaining this is a big challenge. Maintaining this type of architecture is a challenge. Okay, then this can be extended. These have to be extended to other areas like fog computing. Then trust. So how you have to convince the customer to move to edge computing. Okay, first of all, to move to the cloud computing itself, that was a big challenge. Now from cloud, you have to move the customer to edge computing. So for that, you have to build some trust models. Okay, so why will the customer believe in your model? So you have to develop such type of models. Then you have to develop service models. Just whatever I have explained, those are just on theory. So still work is going on. So practically when they are implemented, so you will see the results. So business and service models. So you have to develop those type of service and business models. Then mobility. So when your edges, they have to even support mobile devices, or they have to be in a position to move from one location to another location physically. That is what is a challenge. Then industrial IoT. So a lot of manufacturing units, they are getting automated. Robots are being used. So how your edge computing is going to solve the problems of industrial IoT? So that is one challenge. So these are the challenges that your edge computing is going to face in future. So if you are going to provide, even though the edge computing, it seems to be very interesting topic, but these challenges it has to overcome. Uh, then a small case study. So how your edge computing can be implemented in aquaculture. So this is a small case study I am going to explain. So how your edge computing can be implemented in aquaculture, intelligent aquaculture. Intelligent aquaculture. Aquaculture means you see you have these ponds, chapala cheruvulu, royala cheruvulu. So that comes under aquaculture. Okay. So for intelligent aquaculture. So how you can use this edge computing? So basically, you see here you have these are shrimps. Shrimps means your royalu. So these are the tanks. So a lot of activities a lot of data can be generated from these fish tanks, okay, or shrimp tanks. So what type of data that can be generated is, so your staff, what is the staff related to personal staff, then device, you need some devices, infrastructure, what is the infrastructure, so what is the quality of the environment, what is the oxygen level, what is the freshness present in the water, so all that environment quality, then the biological information about the shrimp. So all this data can be monitored. This is what regularly you can do in an aquatic field. Okay. So what I am doing is, what I am explaining you is now how this can be applied, how this edge computing can be applied for a smart aquatic aquaculture. So what type of electronic devices you can have? So people can use smartphones. Okay, they will be requiring some internet. So for that they need some gateways. You will have security cameras everywhere. Okay, then you have so in order to maintain the temperature, so you might be having some fans inside, or some coolants inside, or you may be oxygen meters you may be having. So all that intelligent controllers. So temperature, their humidity, all that air quality, all that can be controlled. Then smart sensors. So sensors to maintain to measure these the properties of that particular tank. So you need some sensors. So all this can be, again, it can be used. You can use 4G, you can use 5G, or you can use IoT networks. So multi-network integration. So that generally you are going to send it to cloud. Okay, you are going to send it to a cloud. So in the cloud, all that data will be analyzed, and if suppose the temperature is above the acceptable level, so from here a command will go back to this intelligent controller, and what it will do, it will regulate the temperature of this particular pond. Okay, or suppose that in the camera someone is stealing something from this particular lake, or if he is throwing some unnecessary things into this particular tank, so that is captured by the camera. So here automatically that image or video is analyzed and alarms will be blown up. So so it will go to the cloud and again it will come back. So cloud is present at a far location. So till the video is analyzed and till the alarm rings, already that person might have done some damage. So for that, what we are doing now, we are introducing this edge computing. We are introducing that edge computing. Instead of going to the cloud, what are you doing? You can install a small edge near this. So sir, there may be some 20 30 20 30 fish tanks like this. Okay, 20 30. So for all of them you can install one small edge. Okay, not for one fish, not for one shrimp tank or fish tank, for some group of farmers. Okay, you can install edge computing. That is, you can have these servers near that location, all the infrastructure, and you can now manage this automatically. So you don't need a human intervention. So what this edge can do, what this edge computing will give, what facilities it will do, it will intelligently monitor the fish tank. It will check the production management. So how many shrimps are there? The number is increasing or decreasing? What is the quality of that particular shrimp? What is the length of that shrimp? What is the size? What is the weight? Is it healthy or not? Then safety, where it has, if some shrimps, the health of the shrimps also can be monitored. Then equipment. So what equipment you might be using, some equipment in this. So all that can be managed automatically from here. And breeding instructions. So how to breed, so all that information can be passed on to the workers or to the farmers. Breeding instructions. So at what time this food must be given, at what time the tank must be cleaned, how many number of shrimps can be put in one tank, what is the temperature, optimum temperature, what is the quality of the air that should be maintained in the water, oxygen levels, all that can be again done automatically. So instead of using this cloud, okay, you are using the edge. So all that again will be sent back to the cloud. Okay, but you are not involving this cloud. Generally, you are not involving this cloud. Everything is done here. So for a group of farmers, this can be done. So this way, edge computing can be used in the intelligent aquaculture. Similarly, you can use it in transportation. You can use it in hospitals. You can use in bus stands or in airports. So still, what are the considerations? So what in future? What has to be improved? Storage quality, security of the edges, storage present in the edges. Again, bare metal, that is your servers. Bare metal means your hypervisors or your servers, or that is metal in a sense your processors, your processing capability. Okay, so that has to be managed properly. So these are the future improvements that in edge computing you need. So why is this? Edge computing in news. So is this topic important for us? Why should I take a 2-hour lecture on this? Why this has been given as a workshop topic? So it is a very hot topic. You can see in the news when I click in Google edge computing, you see how much work is going on. So how to leverage edge computing. So 10 hours ago, global automotive multi-access edge computing. 18 hours ago, this 6 days ago, 2 days ago, Vodafone, Amazon partner to launch edge computing in UK. Vodafone, AWS, unveil Europe's. So 1 day ago, so 1 week. So much is going on around on edge computing. A lot of research, lot of people are investing a lot of money on edge computing. So whatever I have spoken till now, that is relevant. So the relevance of whatever I have spoken, that I wanted to show you. So edge computing in use. So with this, I end my my talk. Whatever I know about edge computing, I thought to stuff in a 1 hour presentation. So I think I hope I have done justice. And with this, I stop my talk. It was a pleasure talking to you all. Thank you, sir. Samson, sir.
Yes, sir. Hi, sir.
My lecture is finished, sir.
Okay.
Thank you, sir.
Sir. Sir, thank you very much, sir. You have given very wonderful lecture, very simple, and it is very understandable. I hope all of the participants enjoyed with this session, and thank you very much, sir. You have spent a lot of time for us. Previous also you came to our college, and thank you very much, sir, for your cooperation. You are always bond with our college, and mainly students, participants. Now we will give the assessment test link. All of the participants should attempt that assessment test. Then only you will get the this e-certificate. So now, out of thanks. First of all, I thank you very much, Dr. Srinivas Garu, for your valuable lecture today. Yesterday, Dr. Krishna Kirti Madam, for her also, we thank her. And we thank the management of our college, Dr. Uma Shankar Reddy Garu, Director, and Dr. B.S.B. Reddy Garu, Principal, Dr. K.V. Subba Reddy Garu, HOD, and Zubair Basha sir is the faculty ASM coordinator, is the, and participants, thank you very much for your valuable patience to join and take this workshop. And now I invite Zubair Basha sir to say a few words regarding this workshop. Zubair Basha sir, it's a vote of thanks.
Yes, sir.
Already completed, sir. Session, wonderful session completed. You please close this session with your words. We want to close this session with your words. Zubair Basha.
Sir, hello.
Zubair Basha.
Sir, hello. Sir, Velumani speaking, sir.
Tell
Hello.
me, madam.
Sir, actually, I am registered and I am a staff in Power Engineering College, Namakkal district.
We will consider this, madam. We will
That only, sir,
talk
in
later.
feedback and other forms and all, we are getting only the student detail to be filled.
Yes, we will inform this.
Because I handle some elective classes
Yes,
for final
we
year.
will. Okay, madam. We will take this issue to our HOD. We will contact with you. No problem.
Okay, because that after that I should be able to fill that test and everything. No,
Okay,
maybe
okay.
I will get the information or not, sir.
You attempt the assessment test, madam. Okay.
Okay, okay, sir. I think there won't be any limitation for me to attend the test and get
Okay,
certificate,
okay.
right?
We will take this issue to our HOD. We will later. We
Oh,
will
so only I'm asking you to resend that form. So we will be filling the details of the staff and we will also undertake the test, sir.
Okay, okay.
Thank you, sir.
First you
Please
take that. Yes, yes.
give this information in our Telegram group, so we may be able to finish it, sir.
Okay, okay, madam. We will talk together.
So informations were very important, and we found a lot of informations in the forthcoming, what to say, secured world, because we are now in a lockdown period and pandemic. People are in a digital pandemic also. Some people lose money, some people don't know what is the security behind mobile and other things. But now we come across so many things in cloud and other things. So we may know some secure platforms here afterwards, sir.
Okay, okay. We will think.
Thank you, sir. Thank you,
Okay.
sir.
Sir, Zubair Basha, sir. Now I invite Zubair Basha, sir. He is the faculty, ACM faculty sponsor.
Unmute him, sir. Unmute him. Unmute him.
Zubair sir, మీ వాయిస్ వెరీ స్లోగా ఉంది.
He is muted.
No,
ఆయన
sir, he is not muted.
ఆయనది మ్యూట్ అయింది.
ఆయనకి ఆడియో ప్రాబ్లం. సార్ జుబేర్ సార్, మీది ల్యాప్టాప్ ప్రాబ్లం పట్టుకోండి సార్.
Your voice is not audible, sir.
So we can leave the meeting, sir. Hello.
Wait for 5 minutes, madam.
Sir, Velmani speaking. Can we leave the meeting, sir?
Okay, okay, madam. Just 5 minutes.
Okay, sir. Thank you. Thank you.
Sir, I think same problem, sir. Voice is not audible.
Now, sir?
Yeah,
Sir. Yeah, sorry for the interruption due to some of the technical issues which was happened at my laptop. Anyhow, now the whole workshop is completed, sir?
Yes, sir. Completed.
So, completed. So now my role is Vote of thanks, sir, or
Just we want to finish this workshop with your words.
okay, sure, sir. Thanks for giving the opportunity for me to come into this session, joining me into this session. Thanks a lot. Initially, I would like to thanks to the college management who has given the opportunity for all of us to conduct this event without any conflict. They have agreed to conduct this event even whenever we have given the proposal to our college management regarding this event beyond the cloud edge computing. They have been agreed and they have been finalized to conduct this event. I would like to pay thanks to our chairman Shri Kallam Harnad Reddy Garu, as well as the director Shri Umashankar Reddy Garu, and then principal Dr. B.S.B. Reddy Garu. The main key role of this whole event, the edge computing beyond the cloud, is the head of the department who has been behind the scenes, Dr. K.V. Subbareddy Garu, who has been behind the scenes and executed the whole program along with our team, as well as the run show was conducted by our coordinator Shri Mr. Samson sir, who was behind the whole workshop to conduct these two events, right from the designing of the brochure to the then afterwards joining to the students, as well as conducting of this event for the whole 2 days. And the main playback roles of this whole event is Dr. J. Srinivas from SR University from Warangal, and then Krishna Kirti Madam from Dr. Krishna Kirti Madam from Mufakhamja College of Engineering and Technology. These are the two people who has been blended whole their knowledge with the concepts of cloud computing as well as the edge computing. They have given a very good clear-cut interaction on the exposure to cloud computing and the demonstration of the cloud services, deployment models, cloud computing challenges beyond the cloud computing, fog, edge, as well as the Amazon services they have come across. In the yesterday's class, madam was explained in a brief manner, although I was there in the yesterday's talk. And today Dr. Srinivas sir has given a clear-cut thorough knowledge on edge computing architecture for edge computing and devices, how the workload offering for computing systems and resource management in edge computing, security issues in the cloud computing, all these things, the demonstration of the cloud, all these things, he has been given a clear-cut information of the edge computing concepts. Although this topic is in one of the new topics nowadays, which has been prospering widely in terms of conducting research. So I feel that the participants who has been from the various colleges, the students as well as the research scholars, and then the master PG students who have been involved in this as like in this workshop for the today workshop as like a participants, they have been got benefited. I feel so, because these type of events we used to conduct, and hope in the next Monday onwards also we are going to conduct one more faculty development program on the outcome based education. And the July month again we are also going to conduct one more faculty development program on data science and machine learning in collaboration with the NIT Warangal. So on behalf of the ACM student chapter, I pay my vote of thanks to all these people, right from my bottom of the heart, how these people have been taken the pains from the starting of this event to the end of this event, even the participants who have been continuously involved in this event and making this event as like a successful event. Without the participants we could not have did anything. So I would like to pay special thanks to the participants who have been involved in this event and continuously covered the whole 2 days main topics of the whole sessions. And I would like to pay thanks to the people who are behind the scenes, who has been running the show in terms of Google Meet software, as well as the Mr. Mahesh Reddy, who has been running the show of recording the session as well as the conducting the session, taking the attendance and the feedback links. I would like to thank each and every person who has been behind the whole conduct of this workshop. So thanks a lot for giving the opportunity for me. Thank you, sir.
Thank you very much, Zubair sir. Now, thank you once again. Thank you, Dr. Srinivas sir. Now we will close this session. Thank you very much.
Thank you, sir. Thanks a lot, sir.
Thank you very much, sir. Srinivas sir. Oh, thank you.
Sir, now we can stop the recording, sir.
Yeah. Now, all the participants should attempt the test and give
Oh,
the day 2 attendance also. Then
okay,
only we will get the e-certificate. Okay, sir.
okay, okay, sir. Okay, sir. Srinivas sir is left, sir.